So my friends, in today's class we are going to learn the metal cutting, and the important concept in metal cutting is chip thickness ratio. So we are going to learn the chip thickness ratio and how this is related to the shear angle and the rack angle. So as we know, the chip thickness ratio is denoted by R. So and mathematically we can write a chip thickness ratio R equal to T by TC. That is nothing. This T is uncut chip thickness and TC is chip thickness. So before cutting the material we are having a thickness T, and after that it will change into the TC. So this is known as chip thickness ratio. So how this chip thickness ratio is related to this shear angle phi and this rack angle alpha. Now we are going to derive that relation. So this is the triangle we are having AMB, and another triangle we are having A and B. So we can write this T in terms of H. This is shear plane. So I can write T equal to H sin phi. In the similar way, for this right angle triangle, this right angle triangle, I can write TC in terms of H. That is nothing but H cos X. So I can write TC equal to H cos X, and we know that if this is phi, then this pi will become 90 minus phi, and this whole angle will become 90 minus phi plus alpha. This angle, this ABN. Now if this ABN is 90 minus phi plus alpha, then this angle X is nothing but 90 minus, because this is 90 degrees, so this becomes X 90 minus whole 90 minus phi plus alpha, so this will become phi minus alpha. So I can write H cos X. So in place of X I can write phi minus alpha, so this will become H into cos of phi minus alpha. Now let us call this as equation 1 and this as equation 2. So I can divide the equation 1 by equation 2 so that I can get this T by TC. So I can write T by TC equal H sin phi divided by H cos phi minus alpha. So this H got cancelled with this H, so we will get sin phi upon cos phi minus alpha. And now we want to derive the relation between phi and alpha and R. Phi, alpha and R. So I can R equal to sin phi upon cos phi. So I can write R into cos alpha cos phi plus sin phi sin alpha, and that is equal to sin phi. Now this can be written as R. We will divide the whole equation by cos phi. R, this will become cos alpha, because cos phi divided by cos phi equal to 1, and this will become tan phi into sin alpha equal to tan phi. Now this R cos alpha equal to tan phi into 1 minus r sin alpha. So I can write tan phi equal to r cos alpha on 1 minus r sin alpha. So this is our standard relation for determining the shear angle if the rectangle and the chip thickness ratio is given. And this is the important relation, and several questions have been asked till now based on this formula. So I can say this is IMP. And now we will solve the problems on this formula. So now we are given with this GATE 2011 problem, GATE 2001 problem. During orthogonal cutting of mild steel with 10-degree rack angle tool, the chip thickness ratio was obtained as 0.4. The shear angle in degrees evaluated from the data is. So here during this rack angle alpha is given and the chip thickness ratio is obtained equal to 0.4, that is R is given. We have to find out the formula. So here we are having three parameters, alpha, R and phi. So we know the formula that denotes the relation between these three terms. So we can write tan phi equal to r cos alpha on 1 minus r sin alpha. So I can say R equal to 0.4 into cos 10 degree on 1 minus 0.4 into sin 10 degree. So we will get the phi equal to 22.94 degree. Just keep in mind, if you are having a numerical data type question, then you must concentrate on this point. Here it is asked in degrees. If it is asked in radians, then you have to change this into the radian. So just read the question carefully before answering it. Now we will move to the next question. So here we are given with this question, a bar of 70 mm diameter is being cut orthogonally and is reduced to 68 mm by a cutting tool. In case mean length of chip is 68.9 mm and find the cutting ratio to determine shear angle also if the rack angle is 10 degree. So we are given with this question. So first we will write the parameters that are given. So diameter is given. So we know that here the thickness is not given, but by conservation of material, by conservation of mass, or I can say, we cannot say conservation of mass, that is for fluid. So by volume conservation, I can write T into B into L equal to TC into EC into LC. So this here the mean chip length is given, mean length of the chip is given, so LC is given. Let us take this width same as the above, means there will be no change in width, so I can write T by TC equal to LC by L, and I can find out the L here because it is a circular bar, cylindrical bar. So the chip length can be find out by the one perimeter, because if tool move from this point to the same point, then only the one chip will come out. So I can write L equal to pi into 0.07 into 1, or we cannot take. So this will be our perimeter pi d. So I can find out T by TC equal to 0.068 divided by pi into 0.07. So this will become as 0.3, and here we are given with alpha equal to 10 degrees. So we can again apply the formula tan phi equal to r cos alpha from 1 minus r sin. So we can write r equal to 0.3 into cos alpha equal to 10 degree, cos 10 degree upon 1 minus 0.3 into sin 10 degree. So I can get the phi, the shear angle, equal to 17.31 degree. Now here one more question is asked, determine. So here only the chip thickness ratio, here only two parameters are asked, one is chip thickness ratio, one is shear angle, and another one is chip thickness ratio. So we have find out both the things. So we will move to the next question. So here two questions are there that is asked and based on this formula. So we doesn't need to write this formula because it is not required to write this formula, and it is of no use for examination point of view. So we are writing this formula directly. So we can write cos theta plus tan theta minus alpha. This the shear angle can be denoted by theta as well as phi. So we can denote the shear angle by both the symbols, but we will opt this phi. So I can say this first question is 2014. During pure orthogonal turning operation of a hollow cylindrical pipe, it is found that the thickness of chip produced is 0.5 mm. The feed given to the 0 degree rectangle tool is 0.2 mm per revolution. The shear strength produced during the operation. So this is the formula for shear strength. Now in this question, the chip thickness is given, and the uncut chip thickness is also given, and alpha is also given. So 0 degree rectangle, that alpha equal to 0 degree, and T equal to 0.2. Now there is one twist. Now in case of turning, we can write the uncut chip thickness as a f sin lambda. So, and this lambda equal to 90 degree in case of orthogonal turning. But in case of oblique turning, it is not equal to 90 degree. In case of oblique turning, it is not equal to 90 degree. So I can write T equal to this. The feed is given as 0.2 mm per revolution. Just keep in mind this is 0.2 mm per revolution, not 0.2 mm per second or not 0.2 mm per minute. So this must be 0.2 mm per revolution. So I can write 0.2 into sine 90. So that is nothing but 0.2. So now I can write R equal to T by Tc. So that is 0.2 divided by 0.5. So that will become 0.4. Now we have find out the chip thickness ratio. Now we have to find out the shear strength. So we know that tan phi equal to, we have to find out this phi or this theta angle. This theta angle we have to find out. So we will get this theta angle through this formula that we have already derived, r cos alpha upon 1 minus r sin alpha. So I can write 0.4 into cos 0 degree upon 1 minus 0.4 sin degree. So that implies phi equal to 21.80 degree. Now we have to find out the shear strength. So I can write gamma equal to cot 21.80 degree plus tan 21.80 minus 0. So the shear strength will be 2.9 and it is unitless. So this is the important question. Now we have to find out in IS 2009 question, the question asked is minimum shear strength in orthogonal turning with a cutting tool of 0 rectangle is. So this is for IS 2009 question. So minimum shear strength in orthogonal turning with a cutting. Minimum shear strength in orthogonal turning with a cutting tool of 0 rectangle. So we know that the shear strength is denoted by cot phi plus tan phi minus alpha. Now we know that if we want to determine the minimum shear strength, then we have to differentiate this with respect to shear angle, as the rectangle is already given, and we should equate that differential to the 0. So I can differentiate it d gamma by d phi equal to differentiation of cot phi equal to minus of cos x square phi plus differentiation of tan phi minus alpha equal to sec square phi, because this alpha is equal to 0 degree. So if I will make it equal to 0, then I can get cos phi equal to sin phi, and we know that the condition of this cos phi equal to tan phi is only possible if this angle is equal to 45 degree. So I can say this phi angle is 45 degree, and if we differentiate this again, d square upon d phi square, d square gamma upon d phi square, then it will be greater than 0. So this is the case of minimum. So I can say gamma equal to cot 45 plus tan 45. That is nothing but equal to 2. So this is the simple question that is asked. In the similar way, one more tricky question is asked, in which the angle alpha is given with some value. So here it is given with 0 degree, but in the next question it is given with some positive value. So we will look on that question. Here in this question, a single point cutting tool with 12 degree rectangle, so alpha equal to 12 degree is given, is used for orthogonal machining of a ductile material. The shear angle or the theoretical minimum possible shear strength. So we have to find out the gamma minimum, and we have to find out the minimum value, the value of phi for this gamma minimum. So we can write gamma equal to cot phi plus tan phi minus alpha. So I can differentiate it. That is equal to minus of cosec square phi plus sec square phi. So now if I will equate it equal to 0, then I can say cos phi minus alpha equal to sin phi. Now this sin phi can also be written as this cos phi minus alpha equal to cos 90 minus phi. So we can equate these two angles because they are having both sides cos. So I can say phi minus alpha equal to 90 minus phi. So that implies phi equal to 90 plus alpha by 2. And in the above question, the value of alpha is given. So 90 plus 12 divided by 2, that is nothing but 51 degree. And we can find out the value of shear strength. So here we have to find out the value of phi for minimum shear strength. So we have calculated the value of phi. So we can also calculate the value of shear strength. So this is important question, and this might be asked in GATE ME.